Okay, so chapter 4 is about physical layer, which is the bottom layer of the OSI model. Okay, physical layer. Anyway, so this is what we are going to cover. What is the purpose of the physical layer characteristics. Most importantly, we will cover different type of cabling: copper cabling, fiber optic cabling, and different type of copper cabling, okay, and also the wireless media. So the media is very important in the network when you're setting up the network. Okay, so what is the purpose of the physical layer? So obviously, before any communication takes place, there has to be a physical connection, okay, and to carry the signals. So this could be wired or wireless, okay, and if you're so these days if you're in a small like home office, the most signals are carried through the wireless media, okay, but in organizations they're still using wired connection. There are two reasons. Wireless is still not very stable. It has a tendency of interference, especially in a large space. And the biggest problem is the security. So now you know that the network packets, the packets that travel on the network can be captured, okay, and decoded. So for that reason, wireless is not a very secure media. So any organization, every organization has a separate wired network and also a wireless network for other purposes. Okay, so you guys already know that a network interface card connected to the either wired or both wireless networks. Now, not all physical connections offer the same level of performance, meaning the speed, okay, the bandwidth is different depending on the type of media. And also security is also, even like copper media, even though it's physical, but it's still less secure than fiber optic. And you will know after why. And as I said, wireless are the least secure. Okay. So yeah, the job of the physical layer is to transport signals from one device to another device. Okay. And the signal and so the physical layer, which is the bottom layer. So I don't know if you okay, if you remember the OSI model, you have different layers. Okay, so the process is start from the top layer. So let's say you're accessing a web server. Okay, so you're using a web browser. So web browser is the application layer product. So it's a start from the application layer, and it goes down to each layer: transport layer, session layer, network layer, data link layer, and then the physical layer. So each layer performs a function. Okay, so physical layer actually accepts packet from the data link layer. Okay, and then it's encoded into the signals of the media that you are using. So either is a fiber optic cable, either is media wireless signals, or the copper media. Okay, and then they send the signal to the wire, and the signal travels as ones and zeros on the wire and reach its destination where they are de-encapsulated. So, so the TCP/IP standards are encapsulated. There's software in software. So like TCP/IP, web browser, HTTP protocols. They're mostly software. and they cover from applications to half of data link layer. The physical layer deals with cabling and also the ports on the network card. That's the job of the physical layer. And the organization that standardize physical layer devices are these organizations: ISO, EIA, TIA, ITU, NC, IEEE. Why do you need to know this about this organization? Because if you're buying cables, right, make sure they're compatible. So, for example, the most prominent organization that standardize media in North America is EIA, TIA. So when you buying cable, make sure they comply with EIA, TIA standard. So why do you need standards? Okay, what the standard layer dictates. So there is a physical components, and like the cable itself, and also encoding and signaling. So these are because the encoding means what encoding does is it makes both sender and receiver communication compatible. Okay. So the physical components of are the hardware devices, for example, media and other connectors, media and connectors. Okay. And also network interface cards, NIC, and also the interfaces on devices like such as router. Okay. And then cable itself, and also the standard describes the design of these physical devices such as cable connectors. So if there's no standard, what would happen? You would have to buy connectors, because connectors they're a specific size, right? So you would have to buy connectors from this. So if you have 100 computers that you want to connect to each other, if there's no standard, you would have to buy connectors from the same vendor. Okay. Because other vendor could have different size of connector or different shape of connectors. And believe it or not, that was happening in the early days of computing. If you buy a device from IBM, you had to stick with the device. So that's why standards are important. Okay. Okay, what is encoding? Well, encoding converts bits into a format that is recognizable by the next device. So if the next device is using Ethernet, it converts into Ethernet encoding. Okay. One of the most popular method of encoding is called Manchester. We are not concerned about that. We are not electronic engineer. You only have to know the detail of encoding. If, let's say, you want to invent a network card, okay, a faster network card, or you're a manufacturing of hardware devices. But as a network engineer, we are not concerned about encoding, okay? So it's just general, like for your knowledge, how signals are traveled. So signaling is ones and zeros traveling on physical medium. Okay, the method of signaling is different on the different type of medium. Okay, so it depends what type of medium you're being used. So this is signaling, light over fiber optic cable. Okay, this is how it is. So microwave signals over wireless. So this is how the signal travels. Okay, this is electrical signal over copper cable. So this is just for your knowledge. Again, it's not important to know the detail about signaling as a network engineer or a tech support. Okay, so this is just by default, different type of media use different type of signaling method. Oh, So one of the main difference between, let's say, fiber optic and copper media use electrical signals. Okay, fiber optic use light pulses. So when I said about security, like it's not just the speed that makes the difference, that differentiates different media, but it's also the security. Copper cables, cables that use copper as a core are less secure because you can attach, because they use electrical signals, and there are devices they can capture signals that are carried over copper media. Okay, so they're able to capture electrical signal. There are devices, hardware devices, like, I don't know if you guys watch mafia movies where FBI is tapping criminals' phone, right? So that's why, because telephone uses electrical signals. So it's easier to use devices to tap into either telephone network or even the data network. Unlike light pulses, they cannot be captured. So when, for example, bank, they connect their branches, they mostly use fiber optic cable. So the data cannot be stolen that is traveling over the wire. Okay, so the light pulses provide more security. They cannot be, and microwave signals like over the air are the easiest to capture. Okay, the bandwidth, you guys probably have heard of it by now. Everybody should know the speed of the medium. Okay, it's measured in bits per second, kilobit per second. Now it's also measured in terabits per second. Theoretically, there are devices available that can carry terabits per second, that can carry signals terabits per second, but it's only in theory. Okay, I don't know if there's any device commercially available that can carry that provide the speed in terabits per second. But gigabits per second is common. Megabits per second are almost obsolete except the internet connection. But in a local area network, you will not see a megabits per second switches. It's mostly gigabits per second. Okay. Okay, so these are the terms that you will hear a lot, or you will encounter a lot in your networking career. Okay, latency is the amount of time that packet travel from one device to another device. Okay, so that is latency. Okay, is the time. Now, adding multiple devices in your network create latency, meaning every time signal goes through a device such as switch or the router, it creates latency. Okay, it slows down the speed of the packet, right? So that's why you have to be very careful when you're adding devices into your network. So if you add device unnecessarily into your network, it will create the latency. Okay, throughput is a real bandwidth. So you could have a connection 100 megabits per second or 1 gig per second, but the real throughput could be less because you have devices that can create latency. So that will reduce the maximum bandwidth. And also, what other things that can cause degradation of the bandwidth? Number of uh, number of devices on the network. That's why you segment your network. You reduce the number of devices in a network. Like, for example, in our school, we have 7, 8 labs. And if you guys notice, each lab is is a separate subnet. And why it's a separate subnet, meaning it's a separate network? Because it to maximize throughput. If you add many devices in one network, that will compromise the bandwidth. So the throughput is the real speed of the network. Application can also affect the throughput. Some application generate broadcasts, okay, just to function. So these application can slow down the network. For example, any collaboration application for let's say graphic designer. Every company has, well, a lot of company has the graphic design department, and in the graphic design department, most of the user, they collaborate on a project, meaning they share the application that generate a lot of traffic. So what you do is you separate this department in a separate subnet to maximize the throughput in other area of the network. So whatever traffic they generate is limited to them, and it will not affect the other area of network. So you will have better throughput. So it's application. That's why designing a network requires a lot of consideration, a lot of planning and time. Okay. And the good put is the measure of usable data transfer on so the good put is very new term. I just learned it recently. Okay, it's just a term, and to me, if I when I read the example, is just same as throughput. So let's talk about the copper cabling. So in the network, the most popular type of is copper cabling. What does copper cabling means? Meaning the core of the cable, like this is the core, okay, of every cable is made of copper, okay, and they carry electrical signals. Okay, now the consideration of copper cabling is the longer the cable is, the signal lose its strength. If it's far, one device is far from the other device, and this is called attenuation. This is also, you're gonna hear a lot this term in your networking carrier: attenuation, the strength of the signal over distance. Okay, so the copper cannot carry signals as far as fiber optic. Another problem with fiber copper media is electromagnetic interference, EMI. Copper cable signals can be disrupted by many can be disrupted by other electronic devices. So in a manufacturing environment, it's better to use fiber optic cable because they carry light signals, so they cannot be interfere by the electronic devices. Okay, so that's the thing about the copper cable. It's so it is strictly limited to attenuation, meaning the length. Okay, then there are some type of copper cable. They're called shielded twisted pair. They provide the shield to protect from EMI, outside interference. Okay. A crosstalk, this is also a term you're going to encounter frequently. Okay, is crosstalk. Crosstalk is signal interference from an adjacent wire. Okay, if two wires are too close, signal can interference. Okay, so in order to solve this, you twist wires. Twisting wires can reduce the crosstalk. As you can see, so types of copper cabling. UTP, most popular that you always see, and uh, STP is the variation of UTP. It's exactly the same, only it has shielding. Okay, and this shielding protects from outside interference, electrical interference, EMI. Okay, and then you have coax cable. In a local area network, coax cable are obsolete. Couple of years ago or many years ago, you would see copper cable connected from a computer to the switch, or no, not to the switch, but to the router, or they are used to connect computers directly to each other without the use of hub or a switch. But this thing is the thing of the past. You will never see copper cable in a local area network. Now the copper cable is only used as a backbone or to provide internet connection. Okay, like Videotron. So you have cable connection, so that they use copper cable. All right, so the most popular is unshielded twisted pair. So you have 8 wires in unshielded twisted pair, and they're twisted. As you can see, these wires are twisted to eliminate the crosstalk, meaning signal interference from one wire to the other wire. Okay. What are the character? So all these cables are color coded. Okay. So you have solid orange and white orange, solid green, white green. Okay. And so uh, only 4 cable out of 4 are used to carry signals, actual signal. The other 4 cables are used to eliminate the crosstalk for twisting. Okay, so that's why you eliminate the crosstalk. So this is unshielded twisted pair. This is the cheapest type of media, but it's most widely used type of media. Okay, this is good enough for all type of network. Then there's a type of twisted pair cable. It's called shielded twisted pair, or STP. And as you can see here, all the cables are exposed. Wires are exposed. Here in shielded twisted pair, they are cladded in the outer jacket, and also you have aluminum mesh that protects all these wires. So this is to protect from outside interference, okay, electrical interference. So again, I told you these type of cables should only be, and they're more expensive than UTP cable, okay? So these type of cables should only be used in a manufacturing environment, in a laboratory where there are a lot of other equipments. So typically that's where they're used, okay? And both STP and UTP, they use RJ45 connectors, okay? Coax cable, unless you're not working for Videotron, you're not gonna see coax cable much. Okay, they're just your typical cable. Okay, if you have seen, you never. I don't think you have to ever construct a coax cable. When I was learning networking about 25 years ago, yeah, I had to construct, I had to learn how to make uh, coax cable. Okay, how to attach connectors. There are different, but I never had a chance to actually work with the coax cable. Okay, now, so this is, I already explained it to you. So properties of the UTP cabling, this is how it looks like. So in the lab, what we're going to do is we're going to construct some UTP cable. Why we should construct some UTP cable? Okay, these days you can buy cables with different length. But if you see in our lab, I have there are cables, black and green cables that connects your computer to the school network, and they're very long, and these cables are lying on the floor, which is not acceptable at all. It's just in our school. Okay, since it's a lab, so we are using it, but in organizations, the cable should not be lying on the floor. So what you have to do is, if the distance is, so when you buy a cable, they comes in, let's say 7 feet, 10 feet, 20 feet. Okay. So, but what if you need a 15-feet cable, right? So you have to make your own cable. So this is part of your job. Okay. A lot of students have to make cables as part of their task. Okay, so that's why you need to learn. So you have to make custom cables. Sometimes you need a smaller cable for a patch panel. I don't know if you guys remember, patch panel has very small cable. Again, you can buy those cable, but it's cheaper to make those cable yourself. Okay, so you have to make those cable. You should learn how to make those cables. So that's what we're gonna do. Okay, so the twist, I already explained this. The twist between these cable is to cancel the EMI, outside interference, and that's all. So, but I have to show you how to make this cable. So here is it's UTP cable, okay? And when you're making the cable, you have to be careful. The length should be the same of all these pairs. Now, twisted pair cable has different speed, okay? And so therefore there are different categories. Forget category 3, even if you probably so the difference between these category is mainly the speed, how fast a specific cable is. Either it's 10 gig per second, 1 gig per second, or 100 megabits per second. So 3 and 5 are old. Most of the cables are category 6 cables. Okay, they range from 1 gig per second to 10 gig per second. Maybe there is faster, but I haven't checked yet. So these are the most popular, and you have to be careful when you're choosing the cable, because for example, if your company grows, okay, you have more users. So what you can do is you can buy a switch that is faster, okay, and you just replace the older switch with the faster switch. But what about the cable? If you have old cables that can only carry 1 gig per second, even you buy a 10 gigabit per second switch, it will be useless. And changing cables is expensive. Okay, so what you always do is you always go, when you're installing the cable, when you're designing the network, you always go for the fastest cable available if you are anticipating growth. Okay, because probably the cost is not that much different. So these are the connector you use in UTP cables. RJ45, this is poorly terminated, this is perfect. So when you make the cable, I want to see cable look like this, the end, not like this. Okay, now remember straight through and crossover UTP cables. Anybody remember the difference between straight through and crossover? Okay, so straight through between dissimilar devices, and crossover between same devices. So if you're connecting two switches together, you use crossover. Now, keep that in mind. I told you in the lab, some new devices has auto MDIX to sense cable type. So in the newer devices, probably it doesn't make a difference either you use straight through or a crossover cable. But as a network technician, you should always have both straight through and a crossover cable in case you're configuring a device that does not have auto MDIX. Okay. Now, what's the difference? So that's the difference between a straight through and crossover. But how, like technically, how they differentiate from each other? So they're the same cable. It's just the color coding is different. On a straight through cable, both end the color pattern is the same. So, for example, if you want to make a straight through cable, right? Just follow the ITA standard. So this is the standard. This is called T56, T568A, T568B. Okay, so follow this color pattern, follow the standard. So if you want to make a straight through cable, both end of the cables should follow the same pattern, color pattern. So they should start from uh, uh, white green, solid green, white orange, solid blue. Okay, from left to right, and you have to look the connector like this. So the both end are the same color pattern. In a straight through cable, one end is T50 T568A and the other end is T568B. So one end follow this color pattern and the other end follow this color pattern. Don't invent your own color pattern. So what you can do, you can come up with your own, but if you don't follow the standard, then it can create a latency in the network. Okay, so that's why it's very important to follow the color pattern. You can Google it. So let's say if you have to make cables and you don't have the document, whatever, or keep this with you, Google it and follow the standard. Okay. Oh, sorry. Another type of copper cable is called rollover cable, Cisco proprietary. And this cable is used to make console connection from the router or switch to the computer. That cable that you see, the console cable, is called rollover cable. So fiber optic, they're not as common as UTP because they're more expensive, but they're ideal for networking scenarios. For example, they can transmit data longer than uh, uh, copper. So if you have to, let's say, connect two locations that are further apart, right? So copper is 100 meters, fiber optic is 1,000 meters. So that, well, I think I don't know I don't remember the exact distance, right? But this is something, yeah, in that line. So you use the fiber optic to connect branches. Or for example, like so you see in our lab we have switches. These switches are connected to the router so you can have internet access from your room, because the router is in the server room. What if the server room is more than 100 meters? Okay, copper UTP cannot carry signals more than 100 meter. So in that case, you have to use fiber optic cable. And fiber optic also used to create a backbone of the network. What is the backbone of the network? Is all your devices connected to each other. It's called backbone. So, and also they are immune from EMI and RFI. So you can use in a manufacturing environment. Also, because they use light signal instead of electrical signals. Okay, and they use LED or pulses of light, laser LED or pulses of light instead of electrical signals. And the core of the fiber optic cable is either fiber or glass. So there's minimum chance of. So this is fiber optic look like the cable. Okay. Now, in order to make fiber optic cables, you have to be a professional cable installer. Okay. As a network, as a tech support or network technician, you don't have to make fiber optic cable because it requires a special training. Also, excuse me. And also, they require special equipment that are very expensive and they're easily damaged. So the fiber optic cable are expensive, and but installation and manufacturing of fiber optic cable is expensive. That's why they're expensive overall. So as a network technician, you don't have to make fiber optic cable because you don't have that training. In our telecommunication program, that's what they teach, how to make different type of cables. Okay. So the single mode produces single straight path for the light and allows multi-mode allows multiple path. So what's the difference? The core is small and it uses expensive laser and they can use in a long distance application. So therefore they're more expensive. And multimedia fiber are used more. The core is larger, right? And they're less expensive. Okay. And they still can carry up to 10 gigabits per second over 550 meters. So sorry, not 1000 meter, 550 meters. Okay. So where the fiber optic users are most appropriate. So first, in the enterprise networks used for the backbone. Backbone is, let's say you have 10 routers and all these routers are connected to each other. So that's the backbone of your network. Okay. The connection between those routers, not the connection from the router to the switch or the computer, but the connection between the router, because the reason it's called backbone because it carries the traffic of your whole network. Okay. Long haul network. Okay, so the long haul network, because it can carry signals farther. So the networks that connect countries and the cities, and submarine network like under the water connection. Okay, these are the different types of fiber optic connection. Most common is LC, this connector, right? But then you have SC connectors, ST connectors as well. Again, you don't have to, well, you cannot make this cable unless you have a specific training, okay, which we don't cover in our program. So these are the fiber optic patch cords. So if you have a fiber optic switch that connects to another fiber optic switch, you have to use these patch patch cords, like meaning smaller cable. So there are different type of cables. Okay, there's orange, there are yellow. Okay, and the speed is different, either they're multi-fiber or single mode fiber. And this is fiber versus copper. So you see bandwidth UTP 10 megabits to 10 megabits per second to 10 gigabits per second, but fiber optic is from 10 megabits per second to 100 gigabits per second. So it's not just the cabling that you have to invest money. Even so, if you have fiber optic cable, you have to buy switches with fiber optic port, and they can be very expensive. And you also have to buy router if you're connecting to networks, right? With the fiber optic port. 10 gigabits 100 gigabits per second. So just the interface, 100 gigabits per second interface on a router can cost thousands of dollars. So the distance, UTP cabling, short distance, 1 to 100 meters. So actually, I was right. And fiber optic is 1 to 1,000 meters. Okay. And then EMI, low, high, electrical hazard, UTP cabling is low, and fiber optic is high. Okay. And yeah, installation skills required lowest and is the highest in fiber optic. So cabling is very important part of the any network. It takes planning, a lot of planning before you start, even before, even when you choose what type of cable to use. Okay, so you have to think about the environment where you're going to use those cable. You also have to think about the distance, and you also have to think about the future growth, because replacing cable is an expensive endeavor. Okay. Now, next one is the wireless media. As you can see, so what are the problem with the wireless media is the coverage, the area coverage. So if you want to cover a larger area, you have to buy multiple wireless devices. Okay. Wireless signal are prone to interference. Okay. Either by walls or some other devices. Security is low, and it's a shared medium. Anybody can connect to your wireless network, even though you have username and password, but they can be stolen. Unlike copper media, somebody has to physically connect their device to your network. Okay. And since many more user can connect to the wireless network simultaneously, that reduces the bandwidth. So the more user are using a wireless network, the less bandwidth you will receive. So there are different types of wireless media. Okay, so the popular are Wi-Fi. Bluetooth is also a wireless media. You can connect your personal devices, right? You guys know that. Then you have WiMAX and Zigbee, and they're all one thing you have to pay attention to is the standard. So at home, you probably just buy any wireless device, but in a company, you have to pay attention to the standard, because maybe some companies are still using old wireless router that uses 802.11 standard or some different standard. And so make sure when you buy a wireless devices, they're compatible with your existing devices. Okay, so that's why you have to look at the standards. Okay. And anyway, this is something you guys already know. So you need a wireless access point. You have wireless NIC adapter. Okay. And what else? Security is important on your wireless network. You have to create a security policy, meaning sorry, password policy, and you have to enable security, so only the authorized user can access your network. Okay. All right, so this is the end of module 4, chapter 4. Okay.